Ladies and gentlemen, a very warm welcome to IFA 2012 and of course to our international keynotes. It's a big pleasure for me today to introduce you to the first speaker. It's Mr. Phil Rogers. He's President HSA Foundation and Corporate Fellow AMD. Mr. Rogers will talk about the next era of computing innovations. So I wish you a lot of fun and enjoy the keynote.
Good afternoon, everyone. My name is Phil Rogers. I'm the president of the HSA Foundation and a corporate fellow at AMD. And I'm going to be your guide today as we explore the next era of computer innovation. And I'll introduce you along the way to this thing we call the heterogeneous system architecture, HSA for short, and why that is so important going forward. So here we are at a consumer conference. Why are we talking about computers and computer technology? And the answer is, of course, in your pocket. It's on your belt. It's in your shoulder bag. It's the phones, tablets, and notebooks we've come to take for granted every day of our lives. These contain very advanced computers. This is what makes them give the experiences we get today. Computers began moving out of data centers more than 30 years ago, with the advent of the personal computer. Now they've moved into every aspect of our lives. They're in notebooks, e-books, tablets, our cars, phones, televisions. In fact, you may be surprised to learn that there are more than 30 computers in that new car you're thinking of buying, that there are several in your phone, 2 in your refrigerator, and even 1 in your vacuum cleaner. The evolution of computers and the technology that spawns them is a journey. Today, we'll look at where we're at on that journey, and more importantly, where we're headed. And as I guide you on that technology journey, I hope to convince you that in terms of the experiences you have with your technology, we're only just getting started. We at the HSA Foundation have a plan to take all of us on that next 10-year journey of technology. How we take today's experiences and make them even better. In 10 years' time, we may well look back on the devices and experiences of today and find them as quite quaint, primitive even. Much as today we look back on the technology that launched the computer age. Let's start our journey with the first mainframe computer. It was called ENIAC. And it was put into commission in the late 1940s. We measure computer performance in MIPS, or millions of instructions per second. ENIAC was 0.05 MIPS, 50,000 instructions per second. To do that, it took up a large room of equipment and cabling. It weighed 27 tons, and it drew 150 kilowatts of electricity through the wall. To give you an idea how far we've come, today's smartphones typically have processors that deliver more than 500 MIPS. And they do it while drawing only 1 watt from the battery. So yeah, the phone in your pocket, 10,000 times more powerful than the first mainframe computer. And it does it by drawing only 1/100,000th of the power. And yet ENIAC in its day was 1,000 times faster than the machines it replaced. The biggest single leap in computer innovation that ever happened. Televisions in that time also looked a little different. This is the RCA 630, a very popular television of its time. 10-inch screen, black and white, interlaced, flickered kind of like crazy. It was sold as a tabletop TV, but this was a 40-kilogram piece of furniture, a long way from today's high-definition LCD, plasma, or OLED TVs. And telephones. This one didn't have a computer in it. This was the Western model 352 wall phone. Those of us with gray hair remember rotary dialing and not liking friends and family members who had too many zeros or nines in their numbers. This chart shows how far we've come in 60 years with computers. However, we're only scratching the surface of their potential. When we look at the eras of computing, we judge them in what we call in computer design inflection points. And an inflection point is where we have a technology change that changes everything. It changes the machines, the experiences, the buying patterns, and the business models. And we see several in this chart. The growth of mainframes and mini-computers, and then the explosive growth with the arrival of the personal computer. The internet, Windows, MP3 players, mobile phones, the iPhone, Android, tablets, the emergence of cloud services, and the convergence of devices. We're not done yet, not by a long way. It's only natural that we want more from our computer devices. We want them faster, smarter, smaller, thinner, brighter, clearer, greener. We want them to cost less, use less energy, and do more. We want our computers to be more like us, think as fast as we do, and most importantly, anticipate our needs. New technology that redefines how workloads are processed is key to this next era of computer innovation. Ever since the creation of Pong, video and computer games have been a barometer of computer and graphics capability. Let's take a look at an oldie but goodie, Missile Command. Those of us that remember this found it highly addictive. This came out in 1980 and was an Atari arcade game. You can see that by today's standards, the graphics are very primitive. But with every innovation in computers and graphics and user experience, the key is to draw in the consumer and have them enjoy that experience. Now contrast it with a game from 2012.
I gave my baby up for someone like me. If I made you mine, I better call you my queen.
This is a game called Dirt Showdown. It's from a company called Codemasters. It uses the most advanced graphics technology, DirectX 11, and it uses techniques like global illumination and a rendering engine that generates soft shadows and a realism that draws you in. And as you can see with modern games, we're approaching movie quality rendering. We're not there yet, but it's definitely in our future. So when we look at movies, why shouldn't they have the kind of interactivity that we expect in games? And they will. We're just one technological breakthrough away from realizing this future of fully interactive video. And HSA is that technology breakthrough. We're beginning a new stage, a new era of computing where video frames are the unit of processing. Every new device we buy today, whether it's a phone, tablet, notebook, comes with sensors. Microphones, cameras, video cameras. And the video cameras are high-definition video. Video content drives the need for parallel processing and more computing. And video is now an input to be processed, not just a file to be saved or an output anymore. Computer vision is evolving. And computer vision means doing the processing to extract meaning from video camera input. Video's been one way for far too long. Video plays back or video is recorded. Even with video conferencing, we have two streams that pass in the night, but they don't interact. We don't get their meaning. It's time to mess with the video, interact with it, extract its meaning, and bend it to our will rather than observing it passively. The question is how to process all these video and audio streams, how to process them fast and at low power. Computers until now were not designed to do this, but this is exactly what HSA was designed to do. A group of leading technology companies from around the world have come together to drive this next technology inflection. We're going to make media processing much lower power and therefore pervasive. You each have dozens of our processors in your homes, cars, PCs, smartphones, and other devices. We call ourselves the HSA Foundation. Let me introduce these companies and what we do. AMD makes processors, both CPUs and graphics, in a wide variety of end products, from servers to PCs, Macintoshes, game consoles. ARM processors power 90% of the smartphones, 80% of the digital cameras, more than 25% of all electronic devices. They've shipped 20 billion processors to date. Imagination Technologies supply multimedia and communication chips into a host of devices that you're very familiar with. The iPad, the Nook, the iPhone, the Samsung Galaxy. MediaTek makes a wide variety of chips that go into smartphones, digital televisions, set-top boxes, GPSs. Samsung's one of the largest electronics companies in the world. Last year, it sold more than 45 million televisions, more than 95 million smartphones. And Texas Instruments makes more than 80,000 products, and their product portfolio includes everything from smartphones to robotics. So what draws this set of companies together? We're united in a passion for low power and for driving that next era in processing. We're committed to enabling new experiences, devices that don't just do your bidding, but anticipate your needs. Devices that allow you to interact with the world around you, both virtual and physical. Devices you could never again imagine being without. So what is HSA? In essence, the heterogeneous system architecture is an architecture that allows a device to run at much less power when processing media. We're joining together to create a single architecture, a single platform definition for doing this to avoid needless fragmentation. This will create a platform that scales all the way from the smartphone to the supercomputer. And as you can see here, the technology will apply in mobile, desktop, cloud servers, and a whole range of consumer devices. As we look forward, naturally, I can't show you all of the technology that will be here in 5 years or 10 years. That technology is still under development. But let's peek around the curtain a little. I want to give you an idea of how you'll interact with your computers, your devices in this future we're describing. And I want to demonstrate some technology that we and our HSA partners have working today that give you a glimpse into that future. Imagine a world where your electronic devices are always on, always connected. They no longer need to be turned off or unplugged because they have extremely low power consumption in what we call wait for user mode. You don't need to log in because these devices automatically recognize you from the moment when you walk into the room. Typing is no longer required thanks to precise voice recognition and gesture recognition. Most of the time, your devices no longer need to be told what to do. They already know. Take, for example, Amanda in the picture behind me. Her computer is no longer protected by a password she types and doesn't require what we think of today as a login. All it requires is her presence and to hear her voice, and it recognizes her, greets her, and is ready to provide her with content. She doesn't interact with her computer via a mouse and keyboard, nor does she leave fingerprints on the very glass through which she reads articles and watches video. The computer knows what Amanda wants to look at on a weekend morning and presents that content to her in a pleasing manner. Amanda talks to her computer as she would to a friend, and not just with her voice, but her body language. The computer can sense her mood. It can sense if she's interested in work, entertainment, or connecting with people. Today, the computer senses that her eyes are staying on the Olympic diving video, and so it grows that window, and it sees her smile and knows that it's done the right thing and leaves the window large. Something about that video has provoked an emotional response in Amanda. It reminded her of a trip to Australia for the Sydney Olympics that she took with her daughter many years ago. And so she speaks to the computer and says, "Show me videos with Kristen." And the computer switches mode and presents the videos. Takes away the previous content, and it shows video in a preview mode in a 3D UI where every video is already streaming, making it much easier to browse and recognize what you're looking for. But Amanda's not going to browse today. Instead, she says, "Show me the one in Australia." And so the computer knows where every video was taken and who's in them because they've been indexed. And so it presents the video with Kristen in Australia. And it takes it immediately full screen. It doesn't require a user interaction to do that. That's the natural way to present a single video. Instantly, Amanda's flooded with memories from that trip, and she says, well, actually, before she says anything, the computer recognizes that what Amanda is focused on is Kristen, not videos or Australia. And it starts to look for Kristen connected anywhere in the world. And it finds her online in a coffee shop and says to Amanda, "Would you like Kristen to join you?" And Amanda says, "Yes, video." And up she pops. The windows resize, and Amanda and Kristen lock eyes. And the reason they can lock eyes is even though the cameras are around the periphery of the monitor, the computer has the processing power to realign the eye direction so that they're looking at each other in the glass. "Remember the Melbourne Garden Party," says Amanda, and the video moves to that point in its segment. Again, all of the content has been indexed so that video search is now possible. At this point, Kristen and Amanda are in a conversation, they have media, and the computer is not part of their experience. It's receded into the background where it belongs. Now, when you think about how that experience is put together, it's built on several pillars of technology. One is the natural user interface and gestures. A few years ago, we used mice and keyboards and pressed physical buttons. Today, we touch on glass. We poke, we pinch, we spread. It's a better interface, but it's still not great. Does it really make sense to take your hand from the popcorn to the glass to pause and resume a movie and then watch the rest of the movie through a greasy fingerprint? I don't think so. Where we're headed is a world where we bring our fingers up off the glass, a few centimeters on a phone, a few more centimeters on a tablet, above the keyboard perhaps on an ultra-thin notebook, and 3 to 5 meters away from the glass on the wall that we used to call a TV. This will work through a technology we call computer vision, where the cameras on the glass capture your finger movements, and the HSA computer in the device discerns the motion and makes sense of it. Not just hand gestures, think about a voice control system that's better than we enjoy today, where the voice of the machine answers in less than a second, and it's correct more often than it's just amusing. Biometric recognition, those same cameras around the glass will be able to recognize a user to queue up their favorite TV shows when they walk in the room, or to unlock and start their car for them as they approach it. Another important pillar is augmented reality. And augmented reality is where we interfere with the video and we substitute. We may keep the person and substitute a background. We may keep the background and substitute a character, an avatar. This is where real and virtual worlds meet, and it has applications in a very wide variety of areas, from communication to gaming, and especially in education. So at this point, I'd like to do our first demo, and I'd like to look at an example of augmented reality, a virtual presence. In this case, it's technology to improve video conferencing or webinars. So I'd like to invite up Sanjay Patel. He's the Chief Executive Officer of Nuvixa, and he's going to show us some technology in this area. Sanjay?
Thank you, Phil. Hello, everyone. At Nuvixa, what we're doing is dramatically improving the way people communicate with video by making it more interesting, more useful, and more immersive. So let me show you today with a demonstration of our product, Stage Presence. And what I'm doing here is using Stage Presence, which is taking advantage of the Microsoft Kinect camera to first of all locate me, and then using some fairly sophisticated image processing and computer vision to extract me from the stage and put me virtually on the screen. So from a user's perspective, it's quite simple. I take a Microsoft Kinect camera, connect it to my Windows PC, add my content, which could be images or PowerPoint or even video, and then add myself. And my presentation becomes far more compelling with me part of it.
So you don't need this anymore?
Don't need that anymore. In fact, you just saw that. I was able to move forward and backward through my presentation. And I can do this anywhere. I don't need a special background. I don't need a green screen. And thanks to the technology provided by HSA, I can do this using my laptop anywhere. I can do it at work. I can do it at home. I can do it in a cafe with a very crowded background.
Well, so this is, I do a lot of presentations and combined with video conferences, and we always have two screens, one with the video and one with the presentation, which gets very distracting. So you solve that problem by overlaying yourself into the presentation.
Exactly. So you can imagine how this could be very useful for an online meeting.
Yes.
It's a great tool for sales, for marketing, for education, and for training.
Okay, so I see how it works in the business environment, but would there be an opportunity for a consumer at home to benefit from this technology?
Absolutely. I've already got this photo montage up, but you can imagine that when you share photos online, rather than putting up a fairly vanilla photo slideshow, you can create a photo montage that's a combination of you, your video persona like this, your photos, and your voice. So here's a photo montage of a recent family trip. Here's a picture of us in Shanghai. Here's a picture of us in a Ferris wheel. And I believe that's actually my son in that cabin right there.
Yeah, you'd know which cabin he was in.
Yeah, exactly. I can point it out to you directly. And I can take this whole experience and I can share it with you on Skype through screen sharing.
Oh, very nice. And then you can interact with the whole family just through an online account.
Exactly.
Very good. So in terms of technology barriers, when we deliver you more processing at lower power, how would that help your technology?
Well, today, in order for someone to enable stage presence, you require a Microsoft Kinect camera. It's a little large, a little bulky, not terribly portable. But we're imagining a future where you can actually do this with the camera that's built into the screen of your laptop. And in order to do that, we clearly need additional computing power, at very energy efficient points.
Right, because when you've got a stereo camera or two HD cameras built into your device, you have to do a lot of processing to extract the depth information that you get from the external depth camera.
Exactly.
Well, that would be wonderful, because once you can do it with the built-in cameras, then it can become ubiquitous and everybody can enjoy
And
it.
eventually on a mobile device.
Indeed.
That's right.
Thank you.
Thank you,
Very
Phil.
nice. Well, I'd actually like to go immediately to another demo, also on an augmented reality theme. This time, it's a demo about bringing character animation and the creation of avatars, the creation of virtual characters to consumers. And so I'd like to invite up on stage Stefano Corazza. He's the Chief Executive Officer of Mixamo.
Hi,
Thank you.
Phil. Nice to be here. Hi, everybody. Mixamo is a spin-off of Stanford University. We started in 2008. We are based up in San Francisco. And our mission is to democratize character animation. So what we want to do is, we are so passionate about animation that we want to enable anybody, not just to watch animations, but to create them, all the way to consumer. We can show you now a video of a full workflow from creating a character to animating the character, and you can appreciate the type of content that brings millions of people every year to movie theaters. But now, instead of taking years to build it, or days in the best case scenario, we're going to do it just in a couple of minutes. The first one that we are seeing is called Fuse. It's a product that we released in beta about a week ago, and allows anybody to just stitch together different body parts like you are seeing now. These body parts are coming from very high quality models, but here anybody can basically just take those parts and attach them to a character mesh that then we are going to animate. So here we have our character. Maybe we're going to replace those robotic legs with something more suitable for the summer. Maybe with some Birkenstock on. There you go. So now we have our full character. It's just a mesh. We're going to stitch on it also some texture, and then we're going to upload it to Mixamo. So Mixamo is the first online character animation service. People can upload their in-animated characters, just the meshes, and then our server is running some very computationally intensive machine learning algorithms to figure out how to animate those characters. So here I just move a few locators on the body of my character, and then all of a sudden, this is becoming now a living character that can be animated. So the next step would be to choose among the collection of animations that we have, and then create some interesting content, basically. So what we are showing you is basically a revolution in the content creation. We are shifting a paradigm from editing to experiencing. Creating this type of content typically takes days, and it's a very tedious process where you need some very specific technical knowledge in order to do it. Instead, here we are bringing to a more high-level experience, where I can just browse different animations, apply them automatically to my character. Here, for example, we have a walk cycle that we apply to our character, Jimbo. And then now we're going to expose a few sliders where the user can influence the performance. So here I can make it look more brutal or happy, more scary. And with the touch of a few sliders, this is all real time, I can completely change the character and the performance is basically doing. So this very seamlessly comes from the realization that even a 5-year-old can distinguish between a good and a bad animation. And even though he or she doesn't have the technical knowledge to create this content, what we are doing is enabling them, actually, to leap to the other side, from passive spectators to actual creators. And here we can see some fancy dancing motion.
Nice
I think it's a twist. It's kind of old-fashioned stuff, but still works. And I think this concludes our demo about character animation.
Okay, so this is very impressive to bring this to consumers through a cloud service. but I've always understood that the hardest part of character animation is dealing with the face. So what kind of solutions do you have there?
Yeah, I'm going to give you guys a sneak peek on a new technology that we are working on. It's still at the beginning of the research, but facial animation is still is very important because it basically carries so much of the emotion of the character, and it's so important for the overall performance. So now I'm going to give you a quick demo of how this can work on a live camera. So here I have myself. Here you can see how my face is being tracked, and then right now I'm basically doing lip syncing. So the character is talking like I'm doing, then I can go through some expressions.
Don't get stuck.
Like very surprised guy, you know, and very ecstatic. Or I can do some other facial expressions that go more into like the angry face. And you see how these expressions are now naturally, in real time, transferred to the character without having to edit curves or anything, just in real time with a seamless experience. So anybody will be able to do that very easily in their living room.
Wow, and so would the characters with this facial animation be able to upload into online worlds and games?
Yeah, it's something that people are doing already right now. So we have examples, for example, in Second Life, IMView, or games like EverQuest 2, people are already uploading their content in there, and they are enjoying it because it's just such a much more engaging experience to have your own creation of this beautiful form of art that animation is in the game or in the virtual world that you are playing, as opposed to be just a passive spectator. And that's why we are so passionate about it.
Wow, I can see that. And what technical barriers do you face that you want to overcome in the next few years?
So the number one barrier is basically the computationally intensive side of this. The more CPU and GPU we have, the better experience we can create. Animation will be more accurate, more realistic, more believable, and maybe we can be able to track multiple individuals at the same time and animate multiple characters at the same time, all in real time. This is very CPU and GPU intensive processes, so that's why I think HSA can be a big, big promise for us and for what we're doing.
Well, thank you for sharing your technology.
Thank you, Phil.
Stasno. Another area where HSA technology is going to shine is the ever-expanding world of video. And this has three pillars as well. Content everywhere. We expect to be able to access our content, our movies, podcasts, TV shows, any kind of media, anywhere in the world. We'd like to be able to do it indoors and outdoors and take it between our devices. Beyond HD, clearly we love HD experiences, but HD high definition started at 720 and 1080i, which is 2 million pixels. With movie content, we're already on the way to 8 million and 16 million pixels, and of course the Ultra HD will come to all of our devices. And audiovisual content management is key technology because with this deluge of digital data in our lives, how do we manage the rich content? How do we find that clip of video where your son first took his first steps? How do you find that video of your vacation in Australia? We are going to proceed from out of the file system to being able to do full video search and be able to index all of our content, whether it's on local devices or up in the cloud. So let's see another demo here. And this is a case where we tackle the problem of taking our devices everywhere, indoors and outdoors. A big challenge today is how to have a great viewing experience with a color display in bright light. I'd like to invite Michael Touche, CEO of Apical, who's going to show us some ideas. He may have a solution to this.
Thanks a lot.
Thank you.
Right, so we at Apical specialize in making displays adaptive to the viewing conditions. And I'd like to show you some technology we call assertive display that can have a big effect on the multimedia experience on a smartphone or a tablet. Now, we all know the problem. We like to take our devices everywhere, but if we want to watch a movie or play an immersive game, We had better be in a dark room when we do it. Otherwise, the experience may be really poor. And the reason is one of brightness. Outdoors today, it's several hundred times brighter than it is in this room, even though we don't always notice it because our eyes adjust for us. There's a big problem for displays because it means they have to run very bright. That means they have to consume a lot of power. And in fact, on a tablet, the display is the largest consumer of the battery on the device. So we take an alternative approach to this, and our solution is based on processing the pixels of the video stream in real time based on a model of how the human eye works. And let me show you how that works in practice. So if we could watch the video, please. So we're viewing this tablet indoors, but there's a window in the room, and it's daylight. When we're using the UI, there's no problem. But see what happens if we want to watch a movie, or in this case, play an atmospheric game. It's very difficult to see what's going on. There's not much we can see, especially in shadows, because screen reflects off the display. And there's nothing we can do about this with brightness. This is already working at full power. Here we've got two devices, the left with our assertive display, and the right is the standard device. With assertive display on, you can see everything. But on the standard device, many scenes are difficult to view because the content has too high contrast for the display in these conditions. On the left-hand device, we're continuously adapting the video stream to the contrast of the display under the actual viewing conditions. And that's why it looks so natural and like our TV experience. These devices are working at exactly the same power. Here's a game. That game on the right is impossible to play. I have to go into a dark room or close the curtains to have any chance. On the left, again, we're adapting the content so we can see it. Here, we're turning on and off our processing with a button just to show we're not playing any tricks. When it's off, it's very difficult to see what's going on. When it's on, we can see everything. And again, let me remind you, we're not changing the brightness or the power of this display at all. We're just tuning the pixels. Back to that movie again. This movie was intended to be viewed on an HD TV. That has a contrast ratio of 5,000 to 1. This device here has a contrast ratio of around 50 to 1. So we need to help it if it's going to give us the experience that the content creator intended us to have under whatever conditions we happen to be viewing it. This is a challenging case. We've got mixed content. We've got a video window and a UI. Our processing has to be clever enough to only adjust the video and not touch the UI, because that's going to be very distracting if we do that. That's one of the things that makes it challenging. Finally, let's look at outdoors on a sunny day. We wouldn't expect to see much, but let's see what happens if we turn on our processing and play this game. Actually, it's a good experience. I can see everything. I wouldn't be at any disadvantage against an opponent who was sitting in a dark room playing against me. And the overall experience is really, really immersive and satisfying. So, in conclusion, we can take we can go outdoors on a sunny day with a standard display, and we can watch a movie or play a game without killing the battery. And that's what this is all about. Thank you.
That's very impressive. Yeah. So let me see if I understood it. Typically, when we take a color device outside or we're looking at it in a bright environment, we turn up the brightness control. And what that does is it turns up the backlight, which draws a lot of power, but doesn't really help with high contrast. So you're actually reprocessing the pixels and putting different value pixels in the frame buffer and leaving the backlight down so you draw the same or less power.
That's right. The auto backlight function on devices, which is the way of dealing with this normally, is very wasteful and it's ineffective because this is not a problem of brightness, it's a problem of contrast ratio. And that's what we're doing here. We're adapting the contrast ratio of the content to fit the display. And that's why we get this good viewing experience.
Great. So what will HSA do for you? It seems like you've solved a lot of things already.
Oh, yes, I mean, the challenge of this is the processing we need to do is pretty heavy. We have to process each pixel individually in real time with very short latency, so the user doesn't notice. And that means currently we have to do this in dedicated hardware. What we'd really like to do is run this on a processor so it could proliferate very widely across all devices. At the moment, devices need to get more parallel, more memory efficient, and more power efficient to let that happen. And that's the direction the HSA is taking, and that's what we're excited about, and that's why we've joined the foundation.
Well, thank you. And before we close, I mean, we've only known each other for a short while, but I know you're a fairly modest chap. I just hope people realize that for any color display today to be viewable in bright light, it has apical technology. No one else has solved this, right?
I think you're right. I mean, the display industry has spent many years and spent very large sums of money on this issue. But it's a problem that can't be solved by the display alone. And you know, we've got a solution, and it works. So yeah, I think you're right.
Congratulations. Thank you very much,
Thank you.
Michael.
Thank you.
Today, we record video like never before, from our phones, handheld video cams, tablets. This is creating a new generation of amateur movie makers. But today, those movie makers don't have access to the modeling, editing, CGI tools that are used by the professionals in Hollywood and Bollywood. That's all about to change. We'll take a look at a new technology from Otoy that allows you to create high-quality movies from almost any device, with the heavy lifting done in the cloud. I'd like to invite Jules Erbach, he's the Chief Executive Officer of Otoy, to give us a guided tour of this technology.
Thank you, Phil. It's a pleasure to be here. At Otoy, we've been very focused on two technologies. Cloud streaming, where all the processing is done on faraway servers, and the results are streamed in real time to an end device, and very high-end rendering. So when Phil was talking earlier about movies and video games converging, we're at the point where we want to see the high quality that you see in a film like Transformers or Avengers running at with video game interactivity. That's the kind of technology that we're creating. And in order for that to happen as quickly as possible, we've decided to put this technology in the cloud. So to that end, we're actually launching a service for artists, consumers, anyone to use that'll deliver this kind of really unique rendering power as a cloud service. And we're here to show a demo of that today. This will be out in a few months. But let's take a look at my laptop here. This is running just a typical APU. It's not a very powerful laptop. And this rendering that you're seeing here, this is something that would take 40 hours to do on a movie studio render farm. It includes reflections and all these other complex effects that go way beyond not just video games, but even what's used in a film render for a movie. And this is actually not rendering on this machine, it's rendering on a faraway server. But as you can see when I move around, and I'm moving this just by pointing and clicking on the scene, it updates instantly. So we're going from 40 hours to real time. And we're going from millions of dollars of rendering servers to a service that can be streamed to a user for 10 euros a month or a few euros an hour, depending on how much rendering power that you want. From a quality perspective and a simplicity perspective, there's never been a drag-and-drop solution to compete with the likes of George Lucas or Steven Spielberg until now. I mean, we can deliver that by having artists that work with these tools providing their own material libraries, their own techniques, and just through drag and drop, I can completely change the way a scene renders. And this is all running live. This is all running through a stream. And it's actually so intuitive that many complex effects that are not used in films become completely accessible. You just saw depth of field. In fact, the entire camera system is very much like a real physical camera. So when I change the aperture setting, it's no different than me with a real camera changing the aperture on my camera. And you can see here, it does perfect blurring. It's physically correct. And this applies not just to the camera, but to physical materials and objects in the scene as well, whether it's luminous light bulbs or even the sun, which I can just change the position of by pointing to a different place on the map. And as you were just seeing there, I mean, I can turn the sun off, and all of a sudden the entire scene changes. I need to focus my camera a little bit here so you can see better. But this kind of rendering with glass and with lighting and all these complex inner reflections is something that, again, would take hours to render per frame, and here we're delivering it over the cloud in real time and streaming it into a window. There's one other element that we're looking at launching before the end of this year, which takes this concept one step further. And this is our own tool, our own UI that we've created so that artists can get into this right away. But there are 60 million or so users out there that know a 3D tool already, such as Autodesk Max or Maya. And in fact, Autodesk is an investor and partner of Otoy. And what I'm showing here is also rendering in the cloud. And this combines Octane Render, which is our rendering service, with Autodesk 3D Studio Max. And what's interesting is that Autodesk 3D Studio Max is running in the same cloud as the rendering solution. And typically, if you look at these three gray squares, this is how an artist used to work within 3D Studio Max. They would see a rough approximation of their scene, and if they wanted to move the camera around, they would have to wait a long time for that render to update. And as you can see here, while the rendering is instantaneous, no matter what you're doing inside of these scenes, you can actually see the update happening instantly with reflections and depth of field and everything happening completely in real time and completely in the cloud. And what's interesting is this is, in fact, an entire Windows system that we're streaming into this stream. So you have a virtual PC in the cloud. It's streaming at 60 frames a second. There's no latency. And the entire concept of having a computer or how much computing power you have is completely turned on its head. And I'm going to show one more little demonstration of how far we can take this concept. And I'm just going to load this very same session up on an iPad. And this is now running also at 60 hertz interactively on my iPad. I have Windows, I have 3D Studio Max, and I have my rendering power all available in the cloud. And there's absolutely no latency as well. And this is wireless, so there's no wires, there's nothing that's actually stopping this from running with me on anywhere in the world. And this is really exciting because now, companies like Autodesk that have created tools like 3D Studio Max, or these kinds of technologies that can aggregate $1,000, $2,000, or $100,000 of rendering power can stream to a $299 device in real time with no lag, no latency, and that's pretty impressive. And the only other thing that we get questions about when we show this technology is, well, how far away can this work from the server? So we're located in Los Angeles, and we have our server here in Los Angeles running a similar scene. And this is rendering from LA to Berlin, and the latency is basically about a quarter of a second, which is completely usable for interactive scenes. And that's halfway around the world. So anywhere you are in the world, we can deliver this experience, and we can deliver really computing power on demand. And that's something that I think is going to be incredibly disruptive and powerful for consumers and developers alike.
I think that's quite amazing.
Thank you.
So let's link it back to the original situation I outlined. If I'm an amateur movie maker, I've shot some video footage on a Handycam, and now I can create CGI effects up in the cloud. How do I put it all together?
Well, the tools that we're showing running in the cloud, such as Autodesk Max and Maya, can be complemented with video editing tools, such as Autodesk Combustion, Toxic, and Composite, which allow you to blend video that you can upload to the cloud with these kinds of 3D rendering tools that we're creating and adding onto the system. So an end user could use those applications and mix and match the 3D rendering that we're showing today with their own videos and deliver something that looks pretty amazing to YouTube. And I think that's going to empower a whole new generation of content creators. And we're very excited to see that happen.
Oh, I am too. And so, the same final question to you. What are your technological barriers that are holding you back? What kind of service do you want to be offering 5 years from now?
I think 5 years from now, this again is a $299 tablet device. Mm-hmm. Really, we just need the screen and internet connection. So we can imagine a $29 device delivering the same experience with $1 million worth of computing power on the cloud. And those 2 points are going to converge to the point where we think we can deliver really inexpensive cloud computing to really inexpensive devices and have that be supported worldwide.
Very nice. Thank you, Jules.
So much, Phil. Pleasure.
Well, I hope you enjoyed these demos from our foundation members and partners that show some hints of this future ahead of us. As we go through this next inflection point with HSA, our experiences will become truly richer and more immersive. We call this surround computing. Our apps run faster as the media processing becomes more efficient. And with more processing horsepower, we can produce stunning visuals, whether it's to high density, small screens, or to whole walls of glass. More efficient media processing doesn't just mean fast and beautiful, it also means lower power and multi-day battery life. And as we do all this, interactivity goes up with gesture and voice controls at new levels of accuracy. As the keyboard, mouse, and touch screens recede, voice and gesture controls take over, everything becomes easier to use. We see bookmarks working in ebooks today, but imagine the continuity when your web browsing, TV shows, podcasts, movies, and apps follow you automatically from your home to your car to the coffee shop to wherever you go next. This is the vision of the HSA Foundation for the future. As we develop the technology for HSA and bring it to market, the HSA Foundation itself is growing fast. We launched just 2 months ago with an initial set of founder members setting the vision and inviting the whole industry to join us. Just 2 months later, we now have 12 members. And you'll notice that the new members are in a range of technology areas: infrastructure, hardware, software, tools, display, graphics IP. And we expect this tent to become wider as more people come into the fold. We have dozens more companies already in negotiations to join. It's a really exciting time for the HSA Foundation as we gear up to drive that next 10 years of computer innovation. In 60+ years, we've already experienced a lot of changes in computing. We've gone from an industrial computing era to personal computing area, and then to mobile and cloud infrastructure and convergence. And at every step, it's technology inflection points that drove us forward to new and better machines, new and more rewarding experiences. We're on the cusp of that next technology inflection. Today, we see people looking at glass and literally bumping into each other on sidewalks, hallways, and even roads. We spend too much time looking at and touching our devices. It's time to do better and take it to the next level. HSA Technology and the HSA Foundation want to make the computers just disappear from our view, leaving you with the experience instead of the machine. Let's project the visuals where you need them. Let's get your fingers up off the glass. Let's get you walking upright again and driving with your eyes on the road. The next technology transition is going to be profound, and it's going to change the way we live our lives. Again. We at the HSA Foundation will be your guides on that journey, and we'll deliver the technology that makes this change happen. I want to thank our 4 demo presenters today from Nuvixa, Mixamo, Apical, and Otoy for showing the way that they're already trailblazing the way towards the HSA future. And they'll be available after the keynote to answer your questions. And finally, on behalf of the HSA Foundation, I want to say a big thank you to you and to IFA for providing us this opportunity to lay out to you the future of computer innovation. You're going to love the experiences we're going to enable for all of you. Thank you.